If you grew up in the early 2000s, you might remember something called a Tamagotchi. Their clones were all the fad when I was growing up in Istanbul, and at their peak you could find them in every corner store you came across. There aren't many clones left in most stores, and the original ones are a luxury novelty at best, with price tags that's quite offensive to the average Turkish salary. But me and my girlfriend did come across the hidden treasure of a clone of dubious quality in Kadıköy, and turns out the clones age like fine milk. This one didn't even die at night, and you couldn't even choose the pet. We have been bamboozled. Seeing the disappointment of my girlfriend, I have decided to take the matters into my own hands. After soldering the pico and display connectors, I've added a basic screen demo. After that, I've modeled the case for it and printed. Okay, what the actual fuck is that? My 3D printer nozzle got messed up because I was a dummy and used thermal paste that wasn't rated high enough. Should fix that first. I ordered the new nozzle setup online and got to assembling it. Now that the 3D printer is working, I can print and test the first version of the case. It seems there is still a problem with bed adhesion. The grey filament would refuse to stick to the bed, but after changing the filament to EASE and white PLA+, there weren't any more problems and the prints looked perfect. I decided to remake the bottom pad and remove the pull-down resistors on it. Turns out Raspberry Pi Pico has programmable pull-down or pull-up capability when its GPIO pins are set to be digital inputs. Removing the pull-down resistors allowed me to decrease the thickness of the case by a millimeter, and in this project every millimeter counts. This is the new enclosure I designed. I removed the acrylic window openings because it seemed to increase the size and the necessary effort too much compared to the aesthetic values they would bring. I am using heatset inserts to put M3 threads for the back cover to mount on. The screws will pass through both the perf board and the back cover holding the internals as well. I am quite happy with how the device is turning out. The construction is rigid and I think the device will be pretty resistant to mechanical stress. The gaps between the assembly does make it pretty susceptible to moisture though. The connector opening is too narrow for most USB-C and micro USB cables. I removed the back bridge of the opening somewhere down the development by just cutting it. Now that most of the mechanical and electronic parts are ready, I started programming the game itself. After confirming the game is working as it should, I connect the internal battery. I've hooked an ADC port to the internal battery line to measure its voltage, so I can show the charge level on the display. If the charge gets too low, the character will show the tired animation as well. I measure the battery voltage of the fully charged cell for calculating the charge level. I use sandpaper to smooth out and remove the sharp edges where the back meets the front cover. I want this device to be as comfortable to hold as possible. I've also hooked up the backlight to a GPIO output port to switch it on and off digitally. I programmed the key combinations to toggle the backlight, reset the system, and also put the character to sleep, so that it won't go hungry or sad at night. Now that the project is done, I think it looks really nice. The back cover does bulge a bit. As the cable isolation sets in, maybe it will get less bulgy in time. That's probably the only qualm I have with this project. All in all, I think this device, which I've named Tamabunni, came out really nice. I'm proud of it. I just hope that my girlfriend will like it too. And I also hope that she can play with it for long years to come. As upon her request, I've put a keychain hook on the back cover and left the device unpainted. I am curious what kind of modifications she will do to it.
Hepsini yükselttim. Ama mutsuz enerjisi yok. Geçtim. İşte